So are you going to do it?
I am.
Okay.
So welcome to this demo of kafka-delta-ingest. It's funny, I think we have a little bit of a delay on the live stream. So the recording is going to start with you saying, are you going to do it, Christian? So kafka-delta-ingest is a daemon that Scribd has been working on to help quickly and efficiently bring messages streaming in from Kafka into our Delta tables. Scribd as an organization has invested extremely heavily in Delta Lake as a tool and a technology, and we're one of now many contributors to Delta RS, which is a Rust binding that has Python and Ruby support on top of it for Delta Lake. So today in this demo, we have Christian Williams and Misha, who are two of the developers that are working on kafka-delta-ingest. I will be monitoring the live chat should anybody actually have questions as we go along. But please pipe up with questions and I'll try to moderate as possible. And Christian, why don't you go ahead and show us some cool things?
Thank you, Tyler. I'm gonna...
Very natural transition.
I feel like you're trolling me, but that's okay. I will happily share my screen anyway. And I'm going to share a window here where I'm going to demonstrate the Kafka-delta-ingest daemon. And just to kind of complement just a little bit of what Tyler said, I want to mention that this Kafka-delta-ingest daemon is implemented in Rust, and it uses the Delta RS Rust library for managing the Delta transaction log. And I don't want to get too far into the weeds, but I feel like it's worth mentioning here that it does include its own separate write-ahead log for keeping Kafka partition offset commits in sync with data committed to Delta transactions, which is kind of a huge pain in the butt, but something that is necessary if you want to do something like this. So what I'm showing on my screen here is the command line to invoke the Kafka-delta-ingest daemon. I feel like I should actually, if I share a link in the chat, is that going to be visible to YouTube people?
I'll take care of it. I've already shared some links to the source code repo, but go ahead and drop anything to me and I can bring it over into the stream.
Got it. All right. So I have just shared the Kafka-delta-ingest repo link.
We got that. Yep.
Awesome. Thank you. So what I'm showing here is the tool that's implemented within that repository called Kafka-delta-ingest. And I'm about to invoke it with the ingest command. We have subcommands. We don't have any other than ingest yet, but we expect more in the future. So we have subcommands in place. And the arguments that I'm supplying to the tool are the name of the Kafka topic to consume from, the location of the Delta table to write Kafka messages to, and I've got a few other flags here too as well. So I'm specifying allowed latency of 10 seconds, which means we only want, as our consumer is running, we only want 10 seconds to elapse between each Delta transaction. And this is kind of a dial. If you're familiar with the small files problem, you don't want to have a single Kafka message per Parquet row.
So Christian, I want to ask a little bit more of a higher level question there. Let's just assume someone's got only, you know, a little bit of understanding of Delta and the transaction log. Okay. What is it when you say 10? Was it 10 seconds between transactions? What? Give it to me at like a little bit dumber manager terms. What's actually happening there?
So inside of Kafka-delta-ingest, the daemon is going to buffer messages that it consumes from Kafka for 10 seconds before it writes Parquet files and before it writes
Gotcha.
Delta transactions.
All right.
We definitely don't want to, if you were to write a single Kafka message per Delta output file, a Parquet file and transaction, you would have, your readers just would fall apart. They could not like efficiently read that data. Databricks or Delta Lake is a distributed reader system, and you know.
You've answered my question. We can keep rolling.
Okay, thank you. The other flag that I'm using here is a transform argument. The messages that I'm going to be writing to Kafka include a timestamp property, but our Delta table is going to be partitioned by a column that we call date, and that's going to be in the year, month, day format. So without all the minutes and seconds and hours and all that stuff, right? Kafka-delta-ingest provides some, or actually it's pronounced James path, I learned recently. Some James path syntax for doing very simple transformations on the incoming message. So we're going to take that timestamp column, which is in an ISO 8601 format, and we're just going to take the first 10 characters from it. And according to the specification, that's going to be the YYYYY-MM-DD. So I'm going to go ahead and start this. I have my test bed set up properly. And so the daemon is now running. It's consuming from Kafka. It has received a rebalance event because it's just joined the consumer group. It's not consuming messages yet because I'm not writing any messages to the topic yet. So
I'd like to interject here. We don't need to spend any time talking about the wonders of Kafka, but I definitely recommend for anybody interested in using Kafka as a streaming source to bring data into Delta Lake to learn a little bit more about how Kafka manages topics and partitions. It's a very, very useful piece of software, and I think just about any developer that's interested in data systems would benefit from understanding the design and implementation to a certain extent of Apache Kafka.
Excellent. Thank you.
Back to you, Mr. Williams.
Yes, thank you. While you were saying that, it was the perfect opportunity for me to start writing messages to Kafka, which is totally irrelevant to Kafka Delta in itself. But just trust me, I am now writing messages to Kafka. You can see the effect of that on the console that's presented right now. Kafka Delta ingest is running. It's writing a bunch of logs to the screen, to the console, to indicate that it's processing messages.
Hey, there's a different message there for a second. What's going on?
What do you mean?
I saw Delta Lake X'd.
Oh, yeah. Let me a bit.
All right.
This is just, there's a couple different modules inside of Kafka Delta ingest. And so when you see this colon Delta Lake ext, that's just one of the internal modules. And that indicates that 10-second latency that we specified when we launched Kafka Delta ingest, that's completed. And so we wrote a file and we wrote a Delta transaction. So let me go over to a different window for a minute. So Kafka, actually, I don't even need to show this, but for anyone who happens to be familiar with Kafka, this is more evidence that we're actually sending real messages to Kafka right now. I'm running Kafka Cat here on the same topic that Delta Lake's consuming from, and it's showing all the messages that I'm writing to. This is a more meaningful window. I have a watch running here on a local web requests Delta log table. And this is going to be outputting, sorry.
I was going to ask, so up at the top, this is a local Delta table. So you're using like a file system storage.
That's right. Yeah, okay. For the demo, I'm using a file system storage. Interesting. Well, let me. I think I might have kind of screwed up my location here. Let me kind of jump around just a little bit.
Okay.
So every time you see that that slightly different log message that Tyler mentioned,
A writing Parquet file.
Yes.
Yeah.
That means that we have written a new Parquet file and we have written a new Delta transaction. And for Delta Lake readers, that means they're going to be capable of reading the new file that we wrote. If you're running in a Databricks notebook, for example. So I'm actually going to kind of, to some extent, skip past this, but show just in case anyone's interested in understanding in kind of contributing to Kafka-delta-ingest maybe, and maybe understanding how the whole thing works. I'm gonna demonstrate another tool that I use pretty often called Parquet Tools, which is a Python library that's out there and available. And I can take a look at the Parquet files that are being written by Kafka-delta-ingest as they're coming out. And these are going to show me basically the content of the table. So if I scroll up here, or the content of the file that I'm inspecting. So they're going to show me the Parquet schema and all the row values present there. And at this point, I'm going to stop sharing the screen that I'm sharing right now, and I'm going to share a different screen. Because I have, like any good cooking show fan, I have baked a cake already and put it in the oven. And
How Julia Childs of you.
Yeah, exactly. I was thinking Martha Stewart, but I don't know. Rachel Ray. Yeah.
Sure.
So over here in Databricks, which we love Databricks, and that's the whole reason we built this tool, is just to get more and more things into Databricks.
Hey, let Databricks do their own marketing.
All right, we'll do. So we've already got this. All of this data I've copied over to an S3 location that is readable by Databricks, and I have created a catalog entry so that I can query that called example.webRequest that points to all the files that I wrote with Kafka-delta-ingest. And these we see here are the same rows that we were writing to Kafka with that additional date transformation that we showed as well. That is a substring of the timestamp.
So let me recap what we're seeing here. We're seeing a Spark reader query a Delta table, which was written by Kafka-delta-ingest with data that was flowing through Kafka. Correct?
Exactly. Yes, that is
Wonderful.
Correct.
Okay, please continue.
Okay, so that's kind of how the tool works. The whole idea, like we said at the beginning, is we wanted to have a highly performant daemon for ingesting these simple append-only streams into Delta Lake tables from Kafka. That's a huge use case for us, right? And that's what Kafka-delta-ingest is. Its only goal is really, append only with minimal transformations from Kafka straight into Delta, make that data available for any Databricks notebooks or jobs that should be written downstream.
So this is a very good demo. Thank you, Christian. Like what would prevent you from taking what you just showed and putting it into production right now?
Great question. So first off, yeah. So first off, let me rephrase it this way. Can I use this? Probably not yet. No, don't. Kafka-delta-ingest is definitely super early in development still. The demo, in fact, the demo I just gave is based on a hit from an unmerged PR, which will probably be merged in the next couple of days, but many other, patch commits, etc. It's an awesome tool. It's already super useful. You definitely shouldn't use it for prod workloads yet. And can you run it in dev though? Well, yeah, I mean, you could. It's if you want to run this in
it's
a
early
way today, yeah, expect a lot of breaks. The console tool itself, the API is going to probably change. I'm sure there's many bug fixes that will come in, in the very recent future.
So let me ask a question that came in through the chat. What kind of transforms is Kafka-delta-ingest going to support, or does it support today?
Got it. Yeah. So for today, it supports any case. Let me share my screen again. But I'm going to terminate the stream and just use this. So what it supports today are two classes of things. The first is any simple James.
Uh-oh.
So when you see transform, can you
there
see?
you are. Your network cut out for a second. You were starting to say, oh no, there you are again. James path something.
Yes, okay. So we have this parameter called transform, which is a multi-arg thing. Yeah. So the idea here is you can supply multiple transforms in a list from after specifying the transform parameter when invoking Kafka-delta-ingest. So there are two classes of transforms that we support, and both classes are only support transforms within the same message context. You can't do anything like a join or an aggregation or anything like that. Not possible from Kafka-delta-ingest. And the way it works is the expression is very JSON-like. You'll have a colon, and on the left side of that colon, you will have the name of the property that you want your value to be inserted before it lands in the Delta Lake table. So that's basically like, I've got my first version of the JSON message, and I want to add a new property to it. And on the left side, I'm going to say the property name that I want to add. On the right side, I'm going to say the transform that I want to go into it. On the right side, pretty much any James path expression on the message should work if you're familiar with James path. If you're not, neither am I. Or rather, I'm just learning. So no offense there. On the in addition to James path transforms, you can also add a few well-known properties that come from the Kafka message itself. So we have 4 of these right now, and they look like this. So on the right side, I could say I want to add a Kafka offset property to my message. And on the right side, I would say Kafka.offset. And that says, hey, Kafka-delta-ingest, you know about this well-known property called Kafka.offset, which is basically the Kafka offset metadata contained in the message when you're consuming it. I want you to put that in a property on my message called Kafka_offset. And so that works as well. Same thing works for Kafka.property, Kafka.timestamp, and Kafka.topic. And so those are the 2 types of transforms. 1, James path. 2, well-known Kafka metadata properties.
So I'm realizing that we actually skipped over a very important detail of what kafka-delta-ingest does today, and sort of what you're planning to do with it. What types of messages from Kafka can kafka-delta-ingest handle?
JSON only for now.
Just JSON.
Yeah. I could definitely imagine a future where we handle other formats. For now, we're interested in JSON.
All right. I just want to say that I think we're coming close to the end of the demo. If there are any questions, please put those in the YouTube chat, and I'll try to bring those up so we can discuss them. So with that said, with that little plug, call for questions. What's next for kafka-delta-ingest?
So what's next is supporting a higher level of concurrency. At the moment, we've been super focused on just getting a single consumer MVP ready. Ultimately, like, we're going to need to run multiple consumers for really high volume topics. And we have some distributed locking type things that we need to figure out in order to allow multiple processes to handle the same topic to table sync. So that's what's next in line, is we're going to take the single consumer implementation that we have so far, and we're going to make this safe. We're going to make this more concurrency safe so that we can handle bigger workloads.
Someone asked about Avro in the chat, and QP already provided a little bit of an answer. If someone wanted to add support for a different message type, how would you encourage them to get involved?
Well, at the moment, that's going to be ground up involvement. You're going to have to kind of understand the entire code base if you want to add a new format. The format is not well abstracted yet. The cloud storage mechanism is better abstracted. So if you wanted to contribute like an Azure backend for the write-ahead log instead of a AWS DynamoDB backend, it's easier to get off the ground with that. If you wanted to add a completely new format, we just don't have the traits in place right now that would make that easy. But feel free to
getting like a complete understanding of the code base. I should point out that the code base is a little under 1,500 lines of Rust right now. So we're not talking about something enormous, are we?
No, it's not huge. You know, you could, if you were really interested in Avro support, you could probably run through lib.rs and very quickly see, okay, well, this needs to be a trait, that needs to be a trait, and then I can probably add more formats. It's just not something that we're just not ourselves focused on adding support for those other formats just yet. So we haven't made it a priority.
Gotcha.
I also want to point out that there's only been 5 pull requests matched, so it is in early stage.
So early, there's a lot of opportunity for contribution. That's what I'm hearing.
Yes, exactly.
So another question from the chat is, could you maybe, Christian or Misha, you're welcome to jump in. Could you maybe compare and contrast why someone would run kafka-delta-ingest as opposed to deploying a Spark streaming job, for example?
Yeah, I did.
Okay, cool.
So in order to for Kafka-Delta for Spark streaming, right? There is no possible right now solution for auto-scaling if there's work increasing, right? If there's coming more messages into Kafka, basically you need to shut down your cluster, increase the volume, and restart it. But with Kafka-Delta-ingest, with our auto-scaling solution, we're focusing of doing that automatically on the fly, whilst our application is running. So yeah, our auto-scaling solution will be done seamlessly, and I feel like Christian will take you from here with his figures.
Sure. Yeah. Just to kind of put a bow on that, you know, the reason we built this, it really comes into the reason we built it. Like, we didn't like the cost, maintenance, and performance profiles of all the existing solutions, like Spark Streaming. We have a really simple use case. It's append only. We don't have to do a lot of transformation. We don't have to worry about a lot of the transaction conflict, and concurrency management things that come when you're trying to do update, merge, or anything like that, which Spark Streaming is built to handle. We just want to, kind of have a high performance set of Rust daemons running that can just write append only writes into Delta Lake. And so ultimately, like, the application footprint from a few Rust daemons that are doing this append only write is going to be much, much smaller than any of the, heavy-handed tools that have, so much more complexity in them to support the more complex scenarios. We don't we're trying to avoid destroying the anthill with a nuclear weapon. Basically,
That's a metaphor.
Yeah, our metaphor is okay.
I want to add that kafka-delta-ingest, as we have looked at it for Scribd, fits into a fairly comprehensive Spark-based ecosystem. In that, as Christian mentioned, kafka-delta-ingest is this append-only use case. So we basically have a pretty straight line from a Kafka topic to a Delta table that we want to accommodate for here. What we also have sort of waiting in the wings are batch jobs that will do optimize, use an actual Spark batch, Delta optimize, to come in and optimize those tables afterwards, because we're streaming this data into those tables. And then we have on the right side of this diagram just a tremendous amount of Spark workloads that are either streaming the data. We do have a number of Spark streams running, consuming on this data, to do joins and more complex aggregations and things like that. But for kafka-delta-ingest, there's this very critical link between I've got data coming in on Kafka topic that I need to get into the Delta ecosystem so that I can then go do more interesting things within. And so kafka-delta-ingest is for that really straight line from Kafka to Delta Lake. And like one of the things that we had discussions about early on in the project was what is the extent of transformations that we want to perform here? And transformation should really only just be data augmentation here. We're not trying to replace Spark Streaming, which is already very good at what it does. We just need to get stuff into Delta as quickly as possible. Well said.
Yeah. I feel like ingestion is the sweet spot. Yeah. If you've got a stream data logger in your front end that you just want that data available as soon as possible in your data warehouse, that's what kafka-delta-ingest is for. It's not for any analytics. It's not for really complex stuff. It's let's get that data ingested into the warehouse as soon as possible and as cheaply as possible.
I wanted to also make sure to highlight as we move on from that question. We've only got a couple more minutes here. Everything that is being done here and everything that we've shared thus far is open source. This is in the Delta project, so under Delta.io, kafka-delta-ingest. It's Apache 2 licensed, and Christian, Misha, and a few others are also available in the Delta community Slack workspace under the kafka-delta-ingest channel, if you've got more questions about this. One last question before we run out of time. I'm kind of curious, Christian, if you could maybe speak to this. Do you think kafka-delta-ingest will one day work with other streaming sources like a Kinesis or an Azure Event Hub or something that is not Kafka? Or is this tied to Kafka specifically?
Yeah, that's a neat question. The way we built it so far is definitely tied to Kafka, but even having said that, yeah, I've definitely thought about this as well. Like we could abstract the source in all likelihood. I don't see us doing that anytime soon. Like from the script perspective, we're all in on Kafka. We love Kafka, but it's definitely a possibility. Oh, I cannot hear Tyler.
Nope,
Is that
was because
okay?
I just forgot to hit the mute button. One of the nice things about open source is that we do, like, I would love to see more contribution to kafka-delta-ingest, or if someone's really interested in a Kinesis delta-ingest, I think we could also talk about what the properties of Kafka that we're taking advantage of in kafka-delta-ingest and how to map those into a different streaming system. Yeah, there's a lot of really interesting things that are coming down the pipeline with Delta RS as the sort of foundational layer that we're building on top of. Kafka-delta-ingest is one of those. I'm hopeful that in the next few months we'll see a lot more interesting use cases coming on top of Delta that are also, Spark based, not Spark based, Ruby, Python, Rust, Golang. I'm looking forward to more and more stuff in the Delta ecosystem. But with that, I wanted to wrap it up. Misha, thank you for your time. Christian, thank you for sharing the demo. And I think we can call that a day. Thank you, everybody.
Fantastic. Thank you. Bye.